All right. You guys ready to talk about properties of waves or what? Because I'm ready to talk about it. This is going to be so awesome. Properties of waves. Okay, this is it. Frequency, amplitude, wavelength, period, velocity, phase, harmonic content, and envelope. 8 properties. Let's talk about each of these in slightly more detail. I'll just move this over to the side and then let's draw some pictures about it. Oh, there we go. Cool. Okay, I'm going to try and draw a perfect little sine wave here. Something like that. And there's the, I don't know, 0 dB? I don't know what that is. Anyway, you got the line here. Okay, frequency. So this is how many times in 1 second a complete wave passes this line. Okay, so if this whole wave, if it takes 1 second for this wave to go and the whole thing passes through it, then you're at one hertz. All of these we're going to talk about in more detail, but that's the general idea. So how many times a second a complete wave can pass through here? That also equals the pitch. If it's like a musical note, that would be the pitch of the note. So like an A note or a C or whatever. Actually, there's lots of A notes, huh? An A 440 hertz. Okay, let's erase that. That's the long way to erase, huh? How about that? Amplitude. Amplitude is how high the tallest peak to the lowest valley is measured. Apparently it's measured in meters, but I don't know. I think it's also measured in decibels. Who knows? This basically equals the volume or the loudness, or if you're going to get technical, I'm sure they mean different things, but for our purposes right now, it's how loud something is. Okay? Wavelength. Oh, let's get rid of this thing too. You know, I should just make another layer so that I can... no. Let's do that. So I can lock this one and just draw on this one layer. That'll be better. Now let's hide this again. Cool. Wavelength. Okay, that is measuring... Well, we need 2 waves to measure wavelength, huh? 2 identical waves. So that's measuring the top of one wave to the top of the next wave in meters. If you've got a 1 meter long wave, that's a pretty long wave. But you can also measure it in less than meters too, like millimeters or whatever. Okay, from one peak to another peak, that's the wavelength. No, I thought I had locked it. Oh yeah, that's because this is another. Okay, period. This is basically the same thing as time. Okay, so time, this is how long it takes for a complete wave to pass. Okay, so if this is our point of measurement, how long will it take for this whole wave to go through one complete wave? Different from frequency, right? Frequency is how many times it goes through in 1 second. Time is how long it takes for one wave to go. So they are related. They're basically kind of opposites of each other. I don't know. We'll get into the equation for that later, but they are related. Velocity, like the velocity of unladen swallows, this is similar to speed. I'm not a physicist. I don't know what the difference between those two words are, but Basically, for our purposes, the speed of sound waves, that's what we're talking about, it does vary. So like if you're in a warmer temperature, it's going to go faster than if you're in a colder one. And if you have higher air pressure, it affects the speed too. But the variation is minimal enough that it's not going to matter to our ears. It might matter if you're measuring sounds coming from space or something, but for our purposes, sound waves go at 1,130 feet per second. Okay? 1,130 feet per second. That's how fast they go. All of this we'll get into more, but we're just introducing you to these 8 things. Phase. This refers to what direction this stuff goes. So if this is the positive phase of the wave, then the negative would be the complete reverse of that and would look like that. Okay, it's just the mirror image of the wave. And phase is represented by this symbol here. Something like that. That means normal phase, and I might be remembering this wrong. I think it's something like that. Geez, I better look this up before I draw it. Hey, I figured it out. So phase, here's the symbol like that. So if you're running your audio thing and you see a little button that looks like that, that means regular phase. And then when you push it, it's going to switch and look like that, and that means it's inverted, flipped 180 degrees. Boom, there you go. Okay, harmonic content. That refers to what other kinds of sounds are in the wave. So a perfect sine wave is just going to have one wave, make one exact note, and nothing else is in there. But this does not exist in nature. Okay, if I play a note on a piano, it'll play this wave, but then there will also be smaller frequencies in it because that string vibrates in different ways. Okay, so harmonic content, you might have a 200 hertz tone in there, but then you're also kind of going to hear a 400 hertz tone, and you're also going to hear a 600 hertz tone. They're going to gradually get fainter and fainter, but they're kind of in the wave too, so it's kind of like that. You know, that's your harmonic content. And then the envelope. For that, I think we need a totally different drawing right here. Wave envelope. So, like our little picture of a wave. So that's just one wave. But if I hit a note on a piano, that wave goes, you know, because you're holding the note, and so you can hear it for a while. It's not just instantaneous. So the envelope consists of 4 things. We've got attack, we have decay, we have sustain, and release. So these are the 4 properties of an envelope. So when I first hit a note, here, let's draw this. This line is amplitude, and this line is time. So this wave, when I hit the piano note, is going to have some amplitude to it, right? So the attack is going to be the loudest part when I first hit it. So it's really loud like that, right? Still playing the same note. And then you're going to decay. I'm not going to draw the whole wave like that though. Let's just draw this to represent it and pretend it's going up and down. Then you've got some decay like that. Then the sustain is kind of how long the note lasts for after that. And then the release is when you let go of the note and then the sound goes away. Okay, so if I'm playing the guitar, I first hit the string, it's really loud for a second. So that's the attack. How long does it take to get its loudest? If it's a violin, you know, it might take longer because you're rubbing against the string slowly. Attack, if you can read that. Then right after that, it immediately starts to decay, and then it goes here in the sustain, and this is kind of the constant volume as long as you're holding that note. So if I hold the note on the piano, And then once I take my finger off the piano, how long does it take for the sound to go away? Okay, so that all of this whole thing is called the wave envelope. All right, and there we have it, the 8 properties of waves. So we'll go into more detail about each of these in our next series of videos.